This is again, all right, a seduction act in mathematics, in integral calculus for Professor Seco, whose course I audited, turned in an exam, and I'm still negotiating for him to mark that exam. And I may have, gotten one answer out of a math library, math department math library textbook, and my fellow students got the same answer from the same textbook, but it was a very tough course. We are known it's not easy to study, and those were my days. My husband had started work, just recently, back then, and it was really hard. All right for me, more ways than one because those the beginning of spring nights after a tough winter in the basement apartment we lived in on Huron Street before we moved to St. George Street were very warm, and those were the beginnings of my self studies and self that sort of thing. But it was all good. Romantic life was good and that sort of thing. And I was also doing a C programming certificate. So I'm negotiating for an actual grade. I pay for the course and I get an actual grade for this course. It's ordinary differential equations. And we were taught differentiation of a matrix. So you all know kernel of a vector divergence. So you take each element of the matrix and differentiate. When you do, what's the exact term? Hamilton, well, the Hamiltonian is something else. Well, I need to write these down, right? It doesn't come. But kernel, we studied divergence. We studied divergence is, in all three directions. The differential partial PDEs of each expression and that sort of thing. So here goes. All right, my book. So here is A, x1, y2. So 2 by 2 matrix. So integral of A with respect to dx, we have x. All right, so this is distance in x direction, and this is 1 meter, and distance in y direction 2 meters. So I'm just that's what I'm elaborating as, explaining the expressions here, the variables. All right, and the constants. So a dx, integral of a dx. So of course 1 by 1, x squared by 2 x, simple, xy 2x. So you have constant of integrations. So the plus C1, so addition matrix is from row to column, I think. So, but total, so it's all, so this would be total area covered, x squared by 2. So this is x distance, xy, xy would be, what would xy be? Entire area, I guess. Yeah, the entire area. 2x and so x squared by 2 plus 10 constant, row to column. So this to this. I think it can't become more, right? A 4 by 4 itself, it has to be. So based on that, row to column, so this to this and this to this. All right, so that's the resulting matrix. And now explaining what I figured out. All right, so here is a 4 by 4 square. And so this is explaining integration. So I divide it into, this is the basis of integration. Dx is this way, horizontally and vertically. Dx is, so each is 1, 1, 1. So the area is 4 dx square. 4 dx, so it's 1. Area is 1. 1 by, it's all 1. So its area is 1. So now coming back here to my own problem, which I charted out. I'm plotting this out. So this is the plot first, x versus y. So this is, I have how many here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So area underneath the curve is x squared by 2. But how do I prove this? I go back to this plot. All right, so x, and this is y, of course. So this, 4. All right, I stop at 4. 4, x is 4. 1, 2, 3, 4. 4. And then x squared by 2. So this is x1. So this is x squared by 2. And because y is equal to x squared by 2, right? X is here x versus y. And here y is equal to x squared by 2. So x squared by 2. So that's, just basic plots. So this is the curve. So area underneath the curve. So let's approximating this to be a triangle. So I have half base into a height, area of a triangle, half, x is 4, it ends at 4. And height is 8, because y height is 8. Yeah. So 16. Let's see if I got the right answer by integration. Substitution of values, x squared by 2 plus 10. So x squared, x is 8 to 2, x is 4, right? 4 here, x squared by 2, 16 by 2, 8, plus the constant of integration 10, 18, very close, but this is an approximation, it's not an actual triangle. It's this is a curve, so if I were to take it, then I have 16 and 18. I have to bow at this time, or curtsy is more like it, like, you know. So for as a shopaholic, I'm going to buy me a MacBook. All right, how would that be? All the time, dresses, brooches, jewelry. So I feel like a MacBook, Professor Seeker. It would quite do the thing for me at certain times. And sexaholic. I'm going to buy me a Maya 3D student version, computer software, student version. So I think it's okay. So this was promised to me as pay for one successful electric car design, which Autodesk San Francisco and Mazda Protege co-funded, as far as I have been informed, or for a test. So the test was successful. It ran a huge distance too, a long distance, the car, with some changes made to existing cars. That was my first electric car design. Second is complete electric. So as from the day of manufacture, it's manufactured to be an electric car design. So so that's my little story. All right. So the CEOs, let's keep names out of it. All right. Names, but it might look like one stiffed me and the other left me high and dry. All right. Out the window to both you gentlemen until I work on my next electric car design. The mugshot tavern became a shoot-a-shot tavern. I shoot straight for the dick, yours or yours. All right. And the fox and the firkin. Firkin means 9 gallons, which becomes 9 mil of hard liquor. 9 gallons, I mean, who drinks? But, there are Norm from Cheers drinks 9 gallons. I've always wanted to order whiskey on the rocks at a bar, dressed in a slinky slit skirt. Fat chance of this in Toronto in another 3 months. So you should rush it. The paychecks. I say hard is the key word, but I also add I'm hard pressed for luck. Real paycheck luck. All right. So yesterday I did something really wonderful. Next time I will share this. All right. Thank you. Signing off, Gayatri Bisita.